So while the slides are coming up, thank you, Christopher. I think there's a lot of alignment between what you saw about market trends and technologies and what we are doing in the market today in Trimble. I just need my slides on the screen to start. Yeah, sure. A quick introduction. My name is Aviad ALMAGOR. I'm a senior director at Trimble in charge of the mixed reality program and brain-computer interface, which I'll talk a bit about as well. I know Laval Virtual was, in the past at least, more focused on VR, and our focus is mainly on mixed reality. I will explain why, although we see certainly a good amount of use cases which are relevant for VR as well. But our focus is mixed reality, and what you see is what you build is something we will discuss as part of this presentation. But before we start, I'm doing kind of a worldwide survey, going from country to country and ask this question. So I really would like you to collaborate here. Anyone here is familiar with Hatsune Miku? Hatsune Miku? No one? Wow. She's a rock star. So she is 26 years old, 2 million followers on Facebook. Her image is actually on the Akatsuki spacecraft, the Japanese spacecraft. Quite impressive portfolio for a young rock star. And I had the opportunity to experience one of her concerts, and I would like you to experience it as well. She can fill stadiums. It's quite amazing. You should go to one of her concerts. I forgot to mention that Hatsune is a hologram. But her fans doesn't care. I mean, she was born as a hologram, she was raised as a hologram, and thousands of people are joining those shows to see and experience the kind of amazing technology that you see here on the screen. So, certainly this is not the topic of our presentation. We're in this vertical session about construction, but what I would like to show here is that this technology is going into the consumer market. And mixed reality is here to stay, and the consumers are using it on a daily basis already. And a few years from now, it will be difficult for you guys to differentiate between physical object and digital object. And what's the meaning of digital and physical, how those two will be mixed together will be the more important part. And this relates to digital twins on an object level, on our body as well, on cities, and all around the world. So it's about Hatsune. And by the way, for those who are interested, she was just married August last year for a Japanese businessman. Real story. But again, the topic here is construction and the AEC market in general. And what I would like to do is to take you through our journey in the last 6 years, talk about market trends, talking about what we are doing product-wise, and where do we see the technology moving forward. A bit about Trimble. Trimble is a global company, about 13,000 employees, 3 billion annual revenue, and 5 main sectors: buildings, heavy civil, geospatial, agriculture, and transportation. The mixed reality program is a horizontal program supporting all those 5 big sectors. And at Trimble, we are doing hardware and software. A major part of our effort is to bring together the digital world and the physical world. And the reason for this is that we believe that in the gap between the two, between this digital environment and the physical environment, there is a lot of inefficiencies, which impact safety and quality and productivity. And if we can bring those two environments together and merge them, this can bring a lot of value. And I would like to share with you a quick example about the problem we are facing and talk about the solutions. So that's a problem. We have a mental model, and we have reality. And there is a difference between the two. Now, I'm not the only one with this problem in the room, by the way. Now, this might be a very small topic, but now imagine a construction site with thousands of workers, or a mine, or a hospital, where the employees, each one of them, have his own mental model about the task that he needs to perform, which is slightly different from the mental model of his colleagues standing beside him about the task, which is completely probably different from the actual tasks that they need to do. And this is already a catastrophe, and this is happening every day in construction sites, in mine, in production floor. It's part of the life. If we can bridge the gap again, if we can make sure that what I have in my mental model is close to the reality, I'm doing a meaningful thing for the industry, and hopefully can solve this problem as well. So once we understand the potential, let's see where the technology is and how it can help us move forward. What's the maturity level? This is always an interesting question. We also saw in Christoph's slide about where things are. We want to make sure that we have the confidence that technology can help us. And one way to analyze it is to look at this technology graph, the Gartner technology hype. And if we will track it year by year, we can see that almost every technology is moving through those stages, from the initial idea to the point where everyone is thinking, hey, this is going to solve all the problem in the world, just to be disappointed afterward. And when we mature enough, we start to understand what really this technology can give us. And I would like to start actually 20 years ago, 1998.
A collection of New Zealand's weird and wonderful inventions is being showcased at an international event in Christchurch.
Oakley might look a little out of place. That's because he's entering a whole new world. It uses software that's been co-developed by companies HitLab and Trimble.
This system's still in its development stages. They want to make it lighter, smaller, and cheaper. But to see more of this house, I need to put this on. It'll let me walk through the house, even look out the window at the real world.
Mixed reality, 1998, 20 years ago. The technology was not ready back then. The computing power was not good enough. The display was not adequate. The form factor was really bad with a backpack on your. No one wanted to carry this. It was not a commercial product. But the vision about the value of this technology was already there. And now, 20 years ago, thanks to Microsoft and Magic Leap and other companies, we do see the technology in a much more mature state. And based on our understanding, based on our interaction in the market, we know that it is ready for the prime time. We can start using it to gain real value. So back to the present, about 5 years ago, we started to do a proof of concept with Microsoft on the use of mixed reality, HoloLens in this case, for the construction industry, actually for the full length or full cycle of the building industry, from the design to the construction to the facility management. And immediately after this successful proof of concept, we move into a set of pilots all around the world with mining companies, facility management, construction, architectural design. And today we're in a place where we have 4 commercial products to support those industries. And we do expect, based on what we know about the market and the maturity of our customers, to see broader implementation during this year. And I would like to share with you some of the use cases to clarify how this works. And starting with architecture. And in this case, Greg Lynn, he's one of the most prestigious architects in the US today. And he was selected to represent the US in the Venice Biennale, Venice Architectural Biennale. And instead of using this traditional method of presenting his design, it was a very complex design geometry-wise, he decided to use mixed reality. And I would like to show you a short video. So again, this is a traditional way of presenting. We have a screen, we create our digital model, and we can visualize it within this constraint of the 2D screen. But instead, I can take this model and actually place it in the real world, in the physical world, like it is a physical object. And this means that everyone can look at it from any angle. We are kind of democratizing the data. I'm not dictating the point of view as an architect. I just provide you the design, and you can walk around and see it from any angle. It means that I can gain additional information while I'm experiencing my design, like measuring, like querying specific objects. It means that I can actually scale it up and down, unlike a physical model, and visualize specific details to understand the design intention. And in some cases, I can move to kind of a VR experience, actually one-to-one scale, and visualize the model as if I'm inside it, so fully experience the environment. And every step that I will do in the real world will be a step in the digital world. So for architects like Greg Lynn, this is a fantastic technology to explore the design, to accelerate the decision process, to communicate better with the customers, and make decisions in confidence. That's a value in the architectural phase. So let's talk a bit about use cases and how do we see the market. I can roughly divide the use case into six categories that you can see here. And till 2017, most of the use cases and the applications on our side were focusing on design, review, and communication, kind of the lighter side of mixed reality. And it's not by surprise. The technology was not as matured as it is today. The clients were really in an early phase, and it was enough exciting to use it just for communication, just to improve the interaction with the customers and to understand complex situation between, for example, architecture, MEP, structure, and so on, so design coordination. But since 2017 onward, and certainly this year, we start to see more demanding use cases. Ability to use the technology for quality control, production control, and actual productivity kind of task, or production tasks, sorry, and for logistic facility management. So with this in mind, let's take a look at some of the example. And I will start with an augmented reality solution, because as we know, the wearable devices are not very optimized to the outdoor environment. So in this case, we can see a Trimble Sight Vision product. It's a Trimble Catalyst antenna, which provides the accurate positioning for the user, with an Android phone, which provides the AR core capability to make sure that the model, the digital content, is aligned with the environment. And let's take a look what our customers can do with this. In this case, Cold Spring Construction from New York.
Cold Spring was founded by my great-grandfather, and my father was president before me. I take a lot of pride in continuing a family business that's been around for 4 generations. We've always gone out to a job site during the bidding process to look at the area, to identify what challenges there might be. But this is the first opportunity that we've had to use the Trimble Catalyst with the Google software. And what it enables us to do is to go out and look at the design to be constructed, overlaid on the actual site conditions in real time. The ability to actually visualize what's going to be constructed before it happens is an enormous advantage. It's expensive to find a conflict and then go back and have to make that change. This sort of technology will allow us to look at that design before any work is done.
So for Ryan, the CEO of Cold Spring Construction, it's really about saving money and time and improve quality by visualizing the work before he actually need to perform it. The work with Ryan and the work with other customers provide us the opportunity to kind of analyze the market and understand where are the challenges. What do we need to improve? And we realize that there is one very prosaic topic, safety. If we are dealing with devices like Microsoft HoloLens, for example, customers can use it for pilots, but when they would like to go to the construction site or to the mine or to the production floor, they can't just because of this safety reason. And this is why about 2 years ago we started to develop the hard hat accessory for HoloLens 1. And we introduced it to the market, and it was a great success because it really answers the need of a very, again, basic requirement, the safety requirement. And I would like to show you one example from a production floor, talking about use case. I'm talking here about actual production, so what you see is what you build, from Consolis, one of our customers from Sweden. They are experimenting now having mixed reality on the production floor in order to support step-by-step assembly process. No drawings are needed here, no screens, no monitors, just what you see is what you build. Using HoloLens in this case, a team of employees can actually visualize the digital content in front of them and place the objects where they're supposed to be. Quality control is embedded in the process. Again, this is still in a pilot phase, but you can see where the technology is leading us. Sequencing is supported, so if you have new employees, you don't need to train them on the complex assembly process. You can just see step by step the instructions about what should be placed in the next phase. And quality control is also embedded in this process. I can actually understand if what we created is matching the design. So this is what Consolis is doing with the technology. And this is where we kind of decided to move forward into a better integration between mixed reality technology and our customer needs. And we started collaborating with Microsoft on the Trimble XR10, which is basically a HoloLens 2 device fully supporting the frontline workers. It can support construction, mining, frontline work in the automobile, in manufacturing, everywhere where safety is a requirement. There is one more big topic which I think you should consider. It's about synergy. It's pretty rare that one technology transforms a full industry. But if you have several technology working together, this is already a powerful engine for a change. And what we see is a great synergy between mixed reality and other industry trends, like, for example, 3D modeling, IoT, artificial intelligence. And I would like to show you some examples how those technology can work together. One great example is our mining solution. It's actually integration of multiple technologies. So this mining engineer, instead of analyzing the mine condition on the screen, as you can see in the background, he can actually take this technology, mixed reality, and bring together multiple sets of data. For example, I can bring the geometry of the mine coming from Trimble scanners on top of the rim. I can bring the location of the materials, where they were taken from and where they are presented now, and you will see this kind of arcs in the video in a second, by getting this information from our database. I can see the position of the machines in the mine based on GPS technology that's coming from our environment. So let's take a look how this can be done with mixed reality. So here is a mine. Again, the geometry is coming from our scanners. Those arcs represent the materials. I can pick a specific object and get IoT-like information to understand how many hours the engine is working, who is the driver. I can actually enlarge this digital model and visualize the content in more detail. And I can track the machines in almost real time. And again, this is a combination of several technologies which provide us the ability to manage the mine, understand the situation in the mine without being there. Additional synergy, IoT, quite clear. We have this stream of information coming from IoT devices around us, but it's actually bypassing the user to the server somewhere in the cloud. But if you have a mixed reality device and you enter a boiler room, those machines can start speaking with you. This specific machine needed maintenance now, and I should know it as a facility management engineer, and I can actually visualize it. The machine can communicate the information with me with all the database that is available, like manuals, instructions, remote assist, whatever is required to support me in the task in the context of the environment I'm in. So IoT. AI and machine learning, we are now exploring the way to bring together those technologies with mixed reality. And the meaning here in this example is actually quality control and production control. Not just visualizing the mixed environment, the digital and the physical, but actually analyzing actively if the two environments match, if there is any delay in the schedule or if there is any mismatch between the design and the actual production. And maybe the last one, brain-computer interface, which is very exciting technology. If you think about it, when we deal with mixed realities, the world is our GUI. It's not anymore about a screen where we have several menus to control. The content is around us, and we need to be able to control it in this space, in the world, outside. So we are not expected to work with controllers and start to manage the world with those controllers in our hand. We want our hands free. And we have one tool which is with us all the time, our brain. We're exploring now, and this is an early phase, but we're exploring ways to actually interact between users and the environment using their mind. And it can be used for safety, it can be used for manipulating digital and physical assets, and it can be useful for helping us understand what's going on in the user mind, what his experience in a specific facility. And I would like to show one example. We don't have much time to talk about this, but one example, and here we're working with a startup company from Boston called Trimble, and we're using the technology to really understand an experience of a user inside a design, architectural design. And you see the building here. You see on the right side, in the middle, the brain waves, and on the top, the translation of those brainwaves into something meaningful for the users. Probably meaningful for the users. And with this, I can actually understand the user experience. So if you can move one slide forward and click to start the video. What we see here is the eye tracking, providing us the heat map where the user is focusing on. And on the right side, synchronize with it the EEG reading and the translation of this into the user experience, like calm, attention, and so on. This is a fantastic way for designers to present their design with confidence. Hey, this is working. When I put someone in this space, this will be his experience. This will be what he will feel. If I'm building a new hospital, I would like to make sure that the rooms inside this hospital provide the right experience for those users. And today it's a kind of a gut feeling. If I can make this process more kind of evidence-based and brain-computer interface can help me here, this is something very, very meaningful. Let's move to the next slide. So with this, I would like to invite a good friend, Remy Vizuri from GA Smart Buildings. GA Smart Buildings and Remy's team were the first to introduce mixed reality Trimble Connect for HoloLens to the French market. It was pretty impressive a few years ago, with the first introduction of HoloLens actually in the market. And he will talk about his experience with the technology. Thank you very much.